Hello everyone, this is HM64 and welcome to episode 4 of this series on creating a platformer game using only free and open source tools. Previously, we established our platform foundation and underwent testing before releasing it. We also designed all the visual elements such as the player, enemy, tree, plant, flags, and obstacles using Inkscape. In this episode, we will be creating animations for our player and enemy using Blender. Actually, we can also use Inkscape to create animation sprites by duplicating the player or enemy character and changing its pose each time. This method can save some time, but it may require more effort. So let's get into it. Here, as you can see, the player will need to use 5 different animations: idle, walk, run, jump, and crouch. The enemy will only have one animation, which is walk. This means it will be lurking or moving around stealthily. Our animations will be exported as animated sprites or frames that define the pose every millisecond. Characters should have individual parts so that each part can be animated individually. With that said, let's start animating. First, we'll open a new project in Inkscape. Then, copy the player and enemy from the previous project into this new file and scale them up slightly. Next, save the project somewhere on your computer by going to File, Save. By default, it will be saved as an SVG file, which is exactly the format we need to import into Blender for animation. In Blender, go to File, Import, SVG to bring in your file. As you can see, the characters appear very small in the 3D space, so we can scale them up by pressing S and dragging the mouse. The origins of the imported objects are currently set to the world origin, so we need to move each object's origin to its own center. To do that, select all the objects, then click on one of them while holding Shift to make it the active selection. After that, right-click and choose Set Origin, Origin to Center Mass or Volume. This will place each object's origin at its geometric center, making it easier to animate. You might also notice an issue called Z-fighting. This happens when multiple objects occupy the exact same position, causing the graphics card to struggle with which one should be rendered in front. To fix this, we simply move the objects slightly apart. In our case, we'll move them along the Z-axis. Since these are 2D characters, this won't affect their appearance as long as the camera is facing them directly from the front. Now, in order to create this kind of animation, we first need to adjust the object origins properly. The red origin points are currently placed at the center of each object. While that works well for physics simulations, it is not very useful for character animation. Instead, we want the origins to be placed where the joints would naturally exist, similar to how bones connect in the human body. To do that, click on an object and press Tab to enter edit mode. Select the 2 vertices where you want the joint to be, then press Shift plus S and choose Cursor to Selected. This will move the 3D cursor to that exact position. Now press Tab again to return to object mode. Right-click the object and choose Set Origin to 3D Cursor. This will place the object's origin at the joint position, making it much easier to animate naturally. Now, because the leg parts are not physically connected through their joints, we need to parent them together. In Blender, parenting means that if object B is connected to object A, then it becomes the parent and B becomes the child. Any transformation applied to the parent will also affect the child, but not the other way around. We could parent the objects directly to each other, but for better control during animation, we'll use Empties as controllers. Our origins are now correctly positioned, so the next step is to create Empties at those joint locations using the 3D cursor. To do that, select an object, then press Shift plus S and choose Cursor to Selected. After that, press Shift plus A, go to Empty, and choose any empty shape you prefer. To connect an object to an empty, first select the object, then hold Shift and select the empty. Release Shift, press Ctrl plus P, and choose Object or Object Keep Transform. Repeat this process for all the parts. Now all the empties are ready. However, as you can see, the leg parts still behave separately. To fix this, we need to parent the empties to each other as well. Use the same parenting method. Select the child object first, then hold Shift and select the parent object last. Press Ctrl+P and choose Object. This creates a proper hierarchy where the movement flows naturally through the joints. Now bring in the body part and connect the eyes to it using the same parenting method. Next, create an idle pose for one leg, duplicate it, and position both legs under the body. After that, create a new empty object that will act as the main controller for the entire character. Parent both legs to this empty and also parent the body to it. This way, the empty becomes the top-level controller for the whole character rig. At this point, the character is fully set up and ready for animation. Animation in Blender has two main methods, manual keyframing and automatic keyframing. We have this cube and we want to animate it, and we're going to start with the automatic method. First, click the record button over here to enable auto keying. Once I move the cube using the G key and the mouse, Blender automatically creates a keyframe at the exact position of the timeline cursor. It also stores the new transform data inside that keyframe. Here, the transform sliders are highlighted, which indicates that keyframing data is now being recorded on the timeline. To animate, all we have to do is place the timeline cursor on any frame, then move, scale, or rotate the selected object. Blender will automatically create the keyframes for those transformations. It's really that simple. Now click the play button to preview the animation you just created. Once you're done, make sure to turn off the auto keyframing button to avoid creating unwanted keyframes accidentally. Now let's try the manual keyframing method. To save only the current location, go here, right-click, and select Insert Keyframes. You can also choose Insert Single Keyframe, which lets you save data for just one axis in our case. Then move the timeline cursor to another frame. Make some transformation on the cube's scale, rotation, or location, and repeat the same process. If you want to keyframe all channels at once across all axes, simply press the I key on your keyboard. So it's just 3 steps. Set the timeline cursor position. Make changes to the object. Press the key I to insert keyframes for all channels. When you're finished, click the play button and watch your animation. And that's exactly what we're going to do with our character. The only difference is that our object here is a bunch of other child objects, and we need to animate them one by one. And since you know how animation and keyframing works in Blender, I will speed up the remaining part of this video so you can see how I did animate the character. Now let's export the animations. I've added a dedicated camera for each animation and set focal length to orthographic, and I set the image quality to small size like 200 by 200 pixels, because the character is also small comparing to the full game resolution. Next, choose the folder where your frames will be stored by adjusting the output path right here. Once that's set, just press Ctrl F12 to export, or go to the top menu and select Render Animation. Blender exports as a PNG image sequence by default, so you don't need to worry about changing any other settings. Keep in mind that Blender will only render the animation from the currently active camera, so always double check that you have the right one selected. Personally, I like to split my workspace into two views, a standard viewport and a camera preview, so I can easily see exactly which camera is active and avoid any confusion. And that's it! Every other animated object in the game was created using this exact same process. If you found this video helpful, please consider liking and subscribing to the channel. Thanks for watching, have a great day, and I'll see you in the next one.